Okay, so another way for us to run the chi-squared goodness of fit test is to use what we call critical values. And if you have a critical value, which you will always be either given a table and you can find it, or the problem will just tell you what the critical value is. But what you can do is you can compare your critical value to your chi-squared crit value, or excuse me, your chi-squared calc value, and you can then determine if you're going to reject your H sub 0 or not just by using that. So the benefit of chi-squared crit values is you don't necessarily need to find a p-value in order for you to be able to figure if you are going to reject it or not. So you'll be given your significance level, and then you'll be given either the critical value table, which I will show you in a second, or it'll just tell you what that critical value is. But what we can do is if our chi-squared calc value, so the value we get with our calculator, if it is greater than or equal to our chi-squared crit value, then we can reject the null hypothesis. So if chi-squared calc is greater than chi-squared crit, then we are going to reject our null hypothesis, our H sub 0. So our critical values, in order to find them, here is the table. And like I said, you do not have to memorize this. This table will either be given to you or they will just physically tell you what the critical value is within the problem. But notice what it uses. You have to use your degrees of freedom and your significance level. So our degrees of freedom, remember, is our number of categories minus 1. And then you're given your significance. And so let's say we had 6 categories. If we had 6 categories, then my degrees of freedom would be 6 minus 1, which is 5. And let's say we're at 5%. And so we're going to go to our degrees of freedom of 5 and our 5%. And our crit value would be 11.07. And so our chi-squared crit would be 11.07, and then when we run our chi-squared and get our value, then we can compare that to the 11.07, and if our calculated value is greater than our crit value of 11.07, then we can reject our hypothesis. So just kind of reminding you of the steps, we're going to state our null hypothesis and our alternate hypothesis, identify that significant level, calculate our test statistics, so using our calculator, finding that chi-squared crit value by using your degrees of freedom and your significance level, and then determining are we going to reject it or not based on our calculated value and our crit value. And then that very last step is the most important. You are writing a sentence to interpret your decision. Okay, so let's go through a problem here. So we have an internet service provider, we're going to call it ISP, conducts a survey about asking customers how satisfied they were with their service. And it says 5% responded very satisfied, 25% is satisfied, 41% was neutral, 20% is dissatisfied, and 9% is very satisfied. So they want to know, to improve their customer satisfaction, they've made several changes and then repeated that same survey 6 months later. And their new results are shown in that table right there. We want to conduct a goodness of fit test at a 1% level of significance to determine whether these changes were effective. So our H sub 0, if we want to determine if they were effective, then H sub 0 is that the changes were not effective, excuse me. Which then means that our alternate hypothesis would be that the changes were effective. I can't talk, sorry. Okay, our significance level says that it's 1%, so that's 0.01. Our degrees of freedom, well, we have 1, 2, 3, 4, 5 categories. So we're going to have 5 minus 1, which means our degrees of freedom is 4. and our chi-squared crit value. Well, remember it's going to use these two here. So we have a 1% and a degrees of freedom of 4. So if we go back to our table here, let's erase these, and we have a degrees of freedom of 4 at 1%. So our chi-squared crit value is that 13.28. Okay, so now what we need to do is we need to figure out what our L1 and L2 is going to be, and then we will go from there. Whoops, undo. Okay, so I'm just gonna, so L1 is our observed, and then L2 is going to be our expected. So we observed, very satisfied was 25, satisfied was 78, neutral was 77, 36 were not satisfied, and 17 were very dissatisfied. Okay, and then we have to go back to the very top because I'm giving you these percentages here are telling us what that expected percentage is for each category. And we have a total of 233 responses. So 5% of that 233 is very satisfied, 25% is satisfied, etc., etc. So in order for us to do our L2, we're going to have to take that 233 times 5%, and that gives us 11.65. 233, the next category was 25%, so times 0.25, and we get 58.25. 233, the next category was 41%, so times 0.41, and that gives us 95.53. 233 times 20%, which is 0.2, gives us 46.6. And then our last category, 233, is 9%, so that's 0.09. And that is 20.97. So now we have our values, so let's go to our calculator. If you go stat and hit enter, clear out L1 and L2. L1 should be 25, 78, 77, 36, and 17. And then L2 is 11.65, 58.25, 95.53, 46.6, and 20.97. So there are our observed and expected, and then we go to stat, scroll over to test, and scroll all the way down to chi-squared GOF test. Observed is L1, expected is L2. Our degrees of freedom was 4, and then we calculate, and we get a chi-squared value, chi-squared calc is 28.75. And so because of our crit value, now that we know a crit, you could use the P if you wanted to. Our P in this case was 8.78, and compare that to your alpha, just like we did in the past. But you can also now, we know that we can reject it. We're going to reject if chi-squared calc is greater than chi-squared crit. And our critical value was 13.28, and so 28.75 is in fact greater than 13.28, so we are going to reject H sub 0. But in addition to that, if you want to back up your evidence more, you can use that fact that if P is less than alpha, well, our P value is that right? What was our P? 8.78. And alpha was 0.01. Well, that's greater than, which means that we will then reject it as well. Okay, so our conclusion, and I think I might be out of space here, I kind of am, but our conclusion is that the ISP changes, since we are rejecting it, the ISP changes were in fact effective. Since we rejected